A very good morning to all of you children. After a long gap, we are meeting again. So far, we have completed our syllabus. Now, it is very important to revise, and you are getting ample of time. And if you will be serious now, in 4 months, you can do better, a good result. And I think you all will uh, do better in the examination. So, one way to revise the important things is solving the sample papers. That's why from today we will discuss the sample paper. So, it will improve your understanding and help you to clear your doubts and how to present your answers. So, first question is first we are revising chapter 10, reflection and refraction of light. So I have written this question. A concave mirror forms a real image of an object at a distance of 30 centimeter from the mirror when it is kept at a distance of 50 centimeter from the mirror. Then find the magnification of the mirror. Now read the question carefully. If you will go through the question, you will find that a real image of an object is formed at a distance of 30 centimeter. So image distance is given. How much? 30 centimeter. Now think about the sign convention. So real image, and as we know, real images are always formed towards left of the pole, isn't it? Real images are always found towards left of the pole. So V is minus 30 because all the distances which are towards left of the pole are taken to be negative. Now from the mirror, when it is kept at a distance of 50 centimeter, it means when we kept object at a distance of 50 centimeter. So object distance is always negative because it is towards left of the pole. So it is minus 50, and what you have to calculate? Magnification. So we know that magnification M is equal to minus V by U in case of mirror. Now substitute the values. So it will be minus V is minus 30 and U is minus 50. So this minus minus cancel, 0 0 cancel. So you will get minus 3 by 5. And if you will simplify, you will get minus 0.6. It means there is a negative sign in magnification. It means image is formed below the principal axis, and it is correct because a real image is formed. So magnification is 0.6. So in this way you have to solve. Now the second question. The second question is, this is 5 marks question. So we are going to discuss this 5 marks question. The question is, state two positions in which a concave mirror produces a magnified image of a given object. List two differences between the nature of these two images. So let us think about it. So in answer first part, we have discussed the image formation in case of concave mirror, and as you know there are 6 cases. And the cases are when object is at infinity. At that time we are getting an image whose size is like a point, and it is a real image. When object is beyond the center of curvature, the image is again diminished, smaller than the object. When object is at C, then we are getting an image which is also equal to the size of object. And when object is between C and F, it means further if we move the object towards the pole, so when between C and F, then we are getting a real magnified image. So the first case, when object is between C and F. Then think about another case. When object is between P and F, it means between pole and principal focus. Again we are getting a magnified image. So when object is between P and F, you can also ask that why not we can write between when object is at F. Yes, when object is at F, we are also getting a magnified image, real image. But you also see the next part of the question. List two differences between the nature of these two images. It means they indirectly they are asking that you write these two cases in which in one case the image is real and in another case the image is virtual. Because if we will take when object is between C and F, and second when object is at F, then in both the cases images are real. So you will unable to write the differences between the nature of two images. So in this case nature of image is real, and in this case nature of image is virtual. So we have solved the first part. Better to write A and B. Now the second part, differentiate between reflection and refraction of light. So when you have to write the difference between reflection and refraction, whenever you have to write the differences, you must write the differences by making column to get good marks. So first write their definitions. What reflection is, that when a ray of light strikes a polished surface, it bounces back into the same medium, and this phenomena is known as a reflection of light. And for refraction, you can write when a ray of light passes from rare medium or one transparent medium to another transparent medium, it deviates from its path, and this phenomena is known as refraction of light. So I am not going to write their definitions. I think you all know. So in first part you will write their definitions. What reflection is: the bouncing back of light after striking a plain polished surface such as mirror is known as reflection. And similarly you can write for refraction. And then second you can write in reflection, as you know, angle of incidence is equal to angle of reflection. In case of reflection, the angle of incidence is equal to angle of reflection, and in refraction you can write the Snell's law that the ratio of sin I and sin R is a constant for a given color of light and for a given pair of media. This ratio is always constant. So in this way you will write the differences. So these two parts we have completed. Now the third part. In third part, a ray of light is incident on an imaginary surface separating diamond and water. So suppose we have a surface. Here we have diamond and this is water. So a ray of light is incident on an imaginary surface separating diamond and water, given that refractive index of diamond and water with respect to air are 2.42 and 1.33 respectively. So you draw a normal. You have to draw a diagram by showing refracted ray and mark angle of incidence and angle of refraction. So diamond, as you know, it is a denser medium, and the refractive index of diamond with respect to air is given 2.42, and refractive index of water with respect to air is given 1.33. So obviously refractive index of diamond with respect to air is greater than refractive index of water with respect to air. So diamond is denser medium. So if a ray of light will incident, not a straight line, make it straight. Suppose this is the ray of light incident. So in water, when a ray of light passes from denser medium to rarer medium, it moves away from the normal. So this ray will move in this direction. And here you have to mark angle of incidence and angle of refraction. So in this way we have solved third part also. I think it is clear to you children. Now rest of the question we will discuss on Google Meet. Thank you.